In this video, we will practice using the geometric series test and sometimes the nth term test to determine if a series converges or diverges. If you have not yet watched the introductory lesson, you should definitely watch that first. This video will make a lot more sense if you do. You can either click the link that appears in the upper right hand corner or find the link in the description. In the previous lesson, we learned that a geometric series is one that can be written in the form the sum from n equals c to infinity of a times r to the n power. Notice that number 26 is a geometric series with an a value of 1 and r is negative 1/5. We have learned that if an infinite geometric series converges, the sum is equal to the first term divided by 1 minus r. In this case, the first term is a0 because we are starting from n equals 0. But negative 1/5 to the 0 power is equal to 1. So that's going to be the numerator of the sum. The denominator is 1 minus r. 1 minus negative 1/5 is 1 plus 1/5. 1 is 5/5, and 5/5 plus 1/5 is 6/5. 1 over 6/5 is the reciprocal of 6/5, which is 5/6. So that's it for number 26. When a series is not written in sigma notation, you can tell that it is a geometric series if there is some constant that you can multiply by to get from one term to the next. In this case, I see that we are going from 9 to 3. So we're dividing by 3, which is the same as multiplying by 1/3. If I divide by 3 again, that gives me 1. If I divide by 3 again, it gives me 1/3. So in each case, we are multiplying by 1/3, except for the fact that the sign is alternating. Positive, negative, positive, negative. That means we are actually multiplying by negative 1/3. When this happens, you know this is a geometric series, and the r value is whatever you're multiplying by, which in this case is negative 1/3. The sum of the infinite series will be the first term, which is 9, divided by 1 minus r. 1 minus negative 1/3 is 1 plus 1/3. 1 is 3 over 3, and 3 over 3 plus 1 over 3 is 4 over 3. Multiplying by the reciprocal, we have 9 times 3 over 4. 9 times 3 is 27, so that's 27 over 4. So that's the sum of this infinite geometric series. When the rule of a series is the sum of two separate functions, you can rewrite the series as the sum of two separate series. So the original series can be rewritten like this. We can find the sum of the original series by finding the sum of each series individually and then adding the result together. Looking at the first series, we are starting from n equals 0. So the first term will be 0.3 to the 0 power, which is 1. So that's what goes in the numerator. In the denominator, we put 1 minus r. So 1 minus 0.3. But I'm going to write 0.3 as 3/10. For the second series, the first term is 0.8 to the n power, which is 1. And the denominator will be 1 minus r. So that's 1 minus 0.8. And I'm going to write that as 8 over 10. Actually, I'm going to write 8 over 10 as 4 over 5. 10/10 minus 3/10 is 7/10, and 5/5 minus 4/5 is 1/5. Taking the reciprocal of each gives us 10 over 7 plus 5 over 1. We can form like denominators by multiplying by 7 over 7. So the sum of this infinite series is 45 over 7. For the remaining problems, we need to determine if the infinite series converges or diverges. So far we have learned two tests to help us decide if a series is converging or diverging. If we have an infinite geometric series, we can use the geometric series test. For that, we start by considering the absolute value of r. If the absolute value of r is less than 1, the series converges. If the absolute value of r is greater than 1, the series diverges. If the absolute value of r is equal to 1, then we should use the nth term test, which is the other tool that we've learned. The nth term test can apply to any series. We start by considering the limit of the rule as n approaches infinity. If the limit is not equal to 0, the series diverges. However, if the limit does equal 0, it gives us no information. We have to use something else, like maybe the geometric series test. Just for review, I'm going to solve this problem using two different methods. First, I will solve it using the geometric series test, and then I will solve it using the nth term test. We can tell that this is a geometric series because if we take the 1000 from the denominator and put it out in the front as 1 over 1000, now we've written it in the form a times r to the nth power, which means we're looking at an infinite geometric series. So we can use the geometric series test. For the geometric series test, you always start by asking yourself, what is the absolute value of r? And you have to actually write this down. Well, r is 3, so that means the absolute value of r is also 3. But what aspect of this tells us the answer? What's important is that this is greater than 1. You must write greater than 1. According to the geometric series test, if the absolute value of r is greater than 1, the series diverges. But for full credit, you have to finish off by mentioning what test you're using. So we say the series diverges by the geometric series test. For the nth term test, you start by asking yourself, what is the limit as n approaches infinity of the rule? And you have to write this down. In this case, the denominator is a constant, while the numerator is getting bigger and bigger and bigger. So the overall value of the fraction is approaching infinity as n approaches infinity. That means the limit does not exist. Don't put an equal sign in front of it. Remember, for the nth term test, what matters is whether the limit is equal to 0 or not equal to 0. If the limit does not equal 0, then the series diverges. So we have to specifically mention that the limit does not equal 0. When you have does not exist, put it in parentheses. Since the limit does not equal 0, the series diverges by the nth term test. Make sure you mention the nth term test as part of your justification. Number 44 is not a geometric series, so let's try the nth term test. We start by writing the limit as n approaches infinity of the rule. As n approaches infinity, the 4n and the 3n are what matter most. So we will ignore the plus 1 and the minus 1. But then the n's cancel, and the limit is 4 over 3. What aspect of this tells us the answer? Is it that this is greater than 1? Is it that this is greater than 0? Not exactly. What matters is that this is not equal to 0. So the series diverges by the nth term test. This answer has 5 parts to it that are necessary for full credit, so make sure your answers include the setup, the result, the significance, the conclusion, and what test you used. Notice that the nth term test fails for number 48. As n approaches infinity, the denominator gets bigger and bigger while the numerator is a constant, so the overall value of this expression gets smaller and smaller, while actually it gets closer and closer to 0. Be careful, when the limit equals 0, the nth term test gives us no information. It does not prove that the series converges. If we rewrite this expression a little bit, it will be easier to see that this is actually a geometric series. Let's get it into the form a times r to the n. We can start by pulling the 3 from the numerator out to the front. If we pull the exponent outside of parentheses, it's easy to see that we have a geometric series where a equals 3 and r equals 1/5. That means we can use the geometric series test. Let's start by asking ourselves, what is the absolute value of r? Make sure you write this down. R is 1/5, so the absolute value of r is also 1/5. What aspect of this is important? The fact that this is less than 1, so make sure you write down the significance. Since the absolute value of r is less than 1, the series converges by the geometric series test. Number 50 is not a geometric series, so let's try the nth term test. We begin by asking ourselves, what is the limit as n approaches infinity of the rule natural log 1 over n? As n approaches infinity, 1 over n approaches 0. So the question is, what happens to natural log as the argument, the stuff inside, approaches 0? Well, long ago we memorized that the graph of natural log looks like this. As we get closer and closer to 0, natural log approaches negative infinity. So this limit does not exist. What's important about this limit is that it does not equal 0. Make sure you write that down and put it in parentheses. So the series diverges by the nth term test. If we rewrite the expression for number 52 a little, we can more easily see that this is a geometric series. Let's rewrite this in the form a times r to the n. First, if we take n outside of parentheses, we have e to the negative 1 to the n power. Of course, e to the negative 1 is the same as 1 over e. This is now clearly a geometric series, so let's use the geometric series test. We start by asking, what is the absolute value of r? Well, r is 1 over e, so the absolute value is 1 over e. What's the significance of this? What's important is that this is less than 1. E is about 2.72. Since the absolute value of r is less than 1, the series converges by the geometric series test. Notice that the limit of the rule as n approaches infinity equals 0, so the nth term test gives no information.